Hello friends, welcome back to the channel. In this JFrog Artifactory series, in our last video, we looked at how to set up the open source version of Artifactory on a CentOS Linux machine. Today we are going to understand some very important concepts before we jump into the demo. So today we will see what is an artifact, what is an artifact repository, why do we even need an Artifactory in the first place, and especially what is JFrog Artifactory. Before we move forward, it's extremely important to understand what artifacts are and where we keep them, because Artifactory makes sense only when these concepts are clear. So what are artifacts? Artifacts are the files that contain your compiled code along with all the dependencies and resources required for your application to run. In simple words, we can say artifacts are deployable packages. Let's understand this in a simple and a practical way. Whenever a developer writes source code, that code is written in programming languages like Java, Node.js, Python, .NET, Groovy and so on. These are human readable languages. But as we know from school days, computers understand only machine language, zeros and ones. So the developer gives the source code to a build tool such as Maven, Gradle, NPM, Pip, MSBuild, etc. And the build tool converts that human readable code into binary code that machines can understand. Now when that binary code is combined with all necessary libraries, resources need to run the application and the configuration files, all of these are packaged into a single file. That single packaged file is called an artifact. So artifacts are the final output of your build process and they are ready to deploy. If we talk about the examples of artifacts, depending on the technology or language, artifacts may look different. For Java-based application, those can be .jar for Java applications and microservices, .war for web-based applications, .ear for enterprise application archive. For Node.js application, those can be .tar.gz, and for .NET applications, .dll compiled .NET assemblies. For Python, those can be .whl wheel files or .tar.gz source distribution. And there can be others like Docker images and .zip or .tgz packaged builds. No matter the format, remember an artifact is a compiled, ready to deploy version of your application. Now let's understand what an artifact repository is and why we actually need one. An artifact repository is a dedicated server where we store multiple versions of our artifacts. For example, our .jar, .war, .ear, .tar.gz or even Docker images. Every time your build generates a new version of the artifact, that version is saved in the artifact repository. But here is the important point. We don't need artifacts only after the build. We actually need artifacts during the build as well. Let me explain this with a simple real-world Java deployment flow. Well, developers begin by writing source code. Inside that source code, they may use external libraries, dependencies such as Spring Boot, Jacoco, Maven plugin dependencies, etc. In the Java Maven application, all these dependencies are declared inside the pom.xml file. Now, when we run mvn clean install, the build tool needs all those dependencies. So where those dependencies are coming from? It fetches them from public central repository, mainly Maven Central. So during the build process, Maven reads the dependencies from pom.xml file, connects to the Maven Central, download all the required libraries, store them locally in the .m2 repositories, compiles the source code, and finally produces a deployable artifact. So once the build completes and generates the final application artifact, for example .jar, .war file, the output file needs to be stored safely, versioned properly, available for future deployments, and promoted across environments like SIT, UAT, and production. This is exactly where an artifact repository becomes essential. So we push our build output to the artifact repository so that CI/CD pipelines can pull the same artifact, meaning every environment uses the exact same build, no surprises. We don't rebuild the app again in every environment. Deployment becomes faster and reproducible. Deployments become more consistent and reliable, so we eliminate works in dev but not in prod issues. So multiple teams can share and reuse artifacts. So no duplication, everyone uses the same approved builds. All versions stay organized in one central location. We always know which version is where. So even if something goes wrong, we can roll back easily. Just pick an older stored artifact and redeploy it instantly. So this gives us true CI/CD. One build, one artifact, one consistent deployment across all environments. That's why we need an artifact repository. Now let's talk about what JFrog Artifactory is. JFrog Artifactory is an artifact repository, a dedicated place to store your artifacts or binaries. It works exactly like other binary repositories such as Sonatype Nexus. But you may wonder, why do we even need Artifactory? GitHub also maintains versions. Can't we just store our artifacts in Git? So the answer is no. Why? Git is designed for source code management, not for storing binaries. Its job is to track source code change, provide version control, and maintain commit history. So if you start storing binaries inside Git, the repository size will keep increasing rapidly because Git stores history for every single change. Git will duplicate data across versions because it isn't optimized for large files. It slows down cloning, fetching, and pushes if we are keeping large files over there. So even though it's possible, it's definitely not the right tool to store binaries. So what Artifactory does differently? Artifactory is built specially to store archive files, Docker images, any packaged artifact your builds produce. In simple words, Artifactory is a binary repository manager, a version control system for artifacts. So Artifactory uses checksum-based storage, which means it calculates a unique hash for each binary, stores that file only once. If the same version is pushed again, it does not duplicate it. It simply points to the existing stored file. This makes Artifactory extremely efficient in storage. Now let's understand one of the most important parts of JFrog Artifactory, the three types of repositories it provides. The first one is local repository. It is a physically managed repository inside your Artifactory server. This is the place where you push or deploy your own internal artifacts. For example, if you build a Docker image, that image gets pushed into local Docker repo inside Artifactory. Local repositories are manually used to store your organizational artifacts, internal packages, microservice artifacts, client-specific builds. All these artifacts remain inside your environment and can be shared across teams within the organization. So remember, upload is equal to local repository. So that's where your internally generated artifacts go. Next one is remote repo. A remote repository is used to proxy external repositories. These could be Maven Central, NPM registry, PyPy, another Artifactory instance, or any public dependency source. Remote repositories also cache whatever they download. So let's say your build needs NPM dependencies. So Artifactory will fetch them from the public NPM registry once, store them in the remote repos cache, and next time the build runs, it serves them directly from Artifactory. So this improves performance, build speed, reliability, offline availability. So in short, remote repository is equal to proxy plus cache for external dependencies. The third one is virtual repository. A virtual repository is a smart layer on top of your local and remote repositories. We can say it aggregates multiple repos, both local and remote, and exposes them under a single URL. For example, you may have 3 local repositories, 1 remote Maven repo. Instead of configuring all 4 repos separately in your build tool, you simply point your build to a virtual repository. And Artifactory will automatically serve artifacts from local repos for internal packages and remote repos for external dependencies, all through one single endpoint. This simplifies configuration and keeps your builds clean and consistent. So to summarize, we can say you always upload your internal artifacts, your builds, jars, wars, Docker images, etc. to a local repo, and build tools like Maven, NPM, pip, Docker usually downloads dependencies from a virtual repo because it combines both local repos, internal artifacts, remote repos, cached external dependencies. So the client only needs one endpoint. Let's understand the types of JFrog Artifactory repositories and how they are used with the help of this diagram. Inside an organization, everything happens inside the internal network. This is where our build process runs. And right inside the internal network, we have our binary or artifact package manager, which is JFrog Artifactory. Let's first think about how build works without Artifactory. When you build a project, for example Java application, you run mvn clean install. Your build requires third-party dependencies. These dependencies are mentioned in your pom.xml file. Now, if Artifactory is not set up, your machine directly downloads these dependencies from public repositories on the internet, like Maven Central, npm registry, PyPy, and more. Let me show you quickly. If I go to my Visual Studio Code, navigate to my project, which is SCH Students, a Spring Boot Java-based application. But before running the build, I delete .m2 directory, which is located at this PC, C drive, users, admin. Let's delete this. Why? Because otherwise Maven uses cached dependencies. Now I go back to my Visual Studio Code and run mvn clean install. From here we can clearly see it is downloading the dependencies from Maven Central, which is a public repository. And when the build finishes, all the downloaded dependencies appear again inside .m2 repository. So let's go here. This m2 dir directory already created, and here you can see all the dependencies are located. So this is how builds normally work without Artifactory. But inside a company, we do not want hundreds of developers hitting the internet to download dependencies again and again. So what do? We place Artifactory inside our internal network. So Artifactory acts like a smart middleman. It proxies public repository like Maven Central, npm registry, and pip registry. When the build server needs dependencies, it downloads from Artifactory, not directly from the internet. So Artifactory fetches them once, caches them, and then serves them internally. So this improves speed, reliability, security, control over artifact, and zero dependency on internet availability. Now let's talk about the output of build process. When your CI server builds the application, it generates deployable artifacts: jar, var, EAR, node bundles, tar.gz, zip packages, Docker images, etc. These artifacts must be stored somewhere, because we do not run the build again for every environment. The build is done only once. Then the same artifact is deployed to SIT, then UAT, and then production. And this is exactly why we use Artifactory, to store and manage versioned build outputs safely. So this is all about Artifactory repositories and JFrog. If you found this helpful, please hit the like button and subscribe to the channel. In the next video, we will see how to create local, remote, and virtual repositories for a Maven project. Thank you.